but I'm very happy to welcome you all to REEF's 2026 Q1 webinar, Heat Pumps for the Future. And we're going to talk about design, deployment, and preparing the US market for what is next. Next slide, please. So I'm Alicia Khan, I'm the Executive Director of REEF, and I will be your moderator for today's webinar. Next slide. Just some quick housekeeping in case you are new to Google Meet. The way to submit questions is if you look down at the bottom right-hand corner of your screen, there's these 9 dots, and if you hover over that, some tools will pop up, and one of those is the Q&A feature, and you can use that during the webinar. It'll be open for you to submit your questions as you're thinking about them. You can also use this feature to upvote any questions that you would like to see answered, and we'll use this to drive the conversation at the end of the webinar when we go into Q&A. I also want to mention again that we're recording, and we will send you out an email link to the recording when it's ready, as well as to the slides. Next slide. So the lineup for today's speakers is amazing, and we're going to cover a lot of territory and tap into a lot of expertise to make us all a lot smarter about heat pumps and the potential for low global warming impact from this important technology. So we're going to start with Chris Douglas in the center of the screen there, who is a climate policy analyst with the Environmental Investigation Agency, or EIA, which is an NGO that works to reduce greenhouse gas emissions, including both ozone-depleting substances and fluorinated greenhouse gases, or F gases. And standards and codes involving refrigerants have been part of their work for over 10 years, and Chris serves on several UL technical committees and the working group that is harmonizing safety standards. And he's going to share some of that information with us and updates later on in the webinar. Well, then after Chris, we'll hear from Cheryl Winfield from the California Air Resources Board, known as CARB, which is leading the way on progressive policies to address climate change, including hydrofluorocarbon, or HFC, emissions. And Cheryl works on the HFC reduction program, supporting the development and implementation of innovative policies to reduce HFC emissions in California, particularly from the refrigeration and air conditioning sectors. I'm really excited to have Cheryl here. And she'll be followed by Robert Benjamin, who is the founder and CEO of Aris Hydronics, Inc., which is a vertically integrated green HVAC company based in Milwaukee, Oregon. Robert is the inventor of the thermal plant pod system, a patent-pending modular hydronic system delivering heating, cooling, and domestic hot water from an air-to-water heat pump platform. And Robert is a licensed general contractor with over 20 years of experience leading engineering and product design teams. And Aris is one of the few US companies actively piloting R290, or propane, heat pumps in the field, and have won multiple awards, including from DOE and the California Energy Commission. And they're also collaborating with the Oak Ridge National Lab on advancing heat exchanger design. So we've got quite the lineup here. I'm really excited to get into it. Next slide, please. We're going to tackle this topic by starting with some really quick remarks from me on the context for the webinar. And then Chris is going to frame the challenge, specifically getting into the details of code and standard updates for propane heat pumps and other natural refrigerants. And then Cheryl will give us a deep dive into how California's programs are sending policy signals and transforming the market for refrigerants in their state and setting an example for the rest of the country on what's possible. And then Robert will take us home by giving us a flavor of what this looks like in installation and some of the work that Aris is doing with propane heat pumps. And we expect to have a good 15 minutes for audience Q&A to wrap us up. Next slide, please. So just to keep in mind as we move through the next hour, our objectives are to provide some insights into the connection between policy deployment and standards and how all of these are moving forward in parallel to transform the market and enable broad use of heat pump technology using refrigerant with an ultra-low GWP or global warming potential. We also want to demonstrate how propane adoption, or R290, isn't just theoretical, it's really happening. And there are real projects and regulatory signals that are being sent and work underway on safety standards to promote broader application. And then lastly, we want to use propane as an example of how demonstrations, regulatory signals, and safety standards can really move together to build market confidence. Next slide. So I want to just say a few things about REEF if this is the first time that you've joined us. REEF stands for the Refrigerant Emissions Elimination Forum. We're a nonprofit organization working to transform the broader refrigerant landscape toward zero climate and environmental impact. And we do this by supporting building owner action on HVAC and by aggregating leading end user voices to drive market demand. As many of you probably know, most refrigerants used today are HFCs, and as a super pollutant, their impact can be hundreds to thousands of times more than carbon dioxide. So they're really critical to putting the brakes on climate warming in the immediate future to provide time for long-term decarbonization strategies to work. Next slide. So technology adoption requires a process to ensure clarity, safety, cost effectiveness, and market reliability. And we're talking about heat pumps today because they're a technology that's central to replacing fossil fuel systems and to electrification. However, instead of generating heat, they use refrigerants to move thermal energy between spaces. And leaked fluorinated refrigerants are a major problem and an often overlooked climate risk. So propane and other refrigerants with an ultra-low GWP or global warming potential offer a promising alternative, but propane heat pump technologies remain pretty limited in the US despite their widespread use internationally. And part of this is due to unresolved flammability considerations in federal safety standards and building codes. So that's part of our discussion later in the hour. This graphic illustrates what an accelerated state pathway could look like to enable propane or other A3 or referred to as natural refrigerants, and how it can align with regulatory deadlines. So it's really about a market transition that brings together stakeholders, develops guidelines, publicizes demonstration projects, and includes training to strengthen practice. This graphic and the next one both come from some resources on the REEF site, and as I said, we'll share out slides, so you can look for those. Next slide, please. So this is my last slide. I just want to give you a bird's eye view of what we're talking about here when it comes to market transformation for refrigerants by grouping actions into 3 categories. And each of these unlocks kind of a puzzle or part of the puzzle and allows markets to shift forward. So at the top, basically, we want to understand current application and clarify the permitting process, understand where authority lays in that process. And then we want to enable the market, gauging where stakeholders are at, making sure we're paying attention to training, making sure we're doing demonstration projects that are transparent and sharing information across the industry. And in parallel, we want to create structure and certainty for state regulators and for manufacturers. We want to look at the AIM Act and requirements under that, especially for refrigerant recovery and reporting, and also support the safety standards and insurance elements, which are really important to this. So with that kind of ground laid, let's turn to what's happening right now with codes and standards. And Chris will give us an update on the latest in that area. So I'm going to turn it over to Chris.
Awesome. Thank you, Alicia. All right. We can go to the next slide and diving right in with codes and standards. So as many of you may already be aware of, refrigerants are assessed for their flammability and toxicity based on the scale where the numbers increase as the flammability increases, and A versus B. B denotes whether the refrigerant is toxic, like ammonia, for example. And in the US, the two main standards bodies with regard to AC heat pumps and refrigeration equipment are UL, which sets the requirements for equipment design and construction, and ASHRAE, which broadly speaking is the equipment installation requirements. So if we go to the next slide, here we can compare how the global landscape looks with the IEC standards compared to the US and our domestic UL standards in terms of the maximum charge size for flammable refrigerants, specifically A2 and A3 refrigerants. The US has this capped right now at 114 grams for A3s. And if you compare that to the IEC, that's almost 1 kilogram for the indoor direct systems and 5 kilograms for the outdoor indirect systems. That 114 gram cap right now makes it very difficult for any equipment to operate at any significant capacity level. So obviously the primary barrier here is the safety concerns. Now, while IEC has approved these larger charge sizes for A2 and A3 refrigerants, they're already installed in Europe and in Asia, parts of South America. US standards and codes have to conduct and review their own research domestically, owing to some of that research not being public, in addition to differences with building code and equipment design, liability laws, and also just a general preference for more physical testing to confirm safety and mitigation methods. So if we go to the next slide, we'll see a approximate timeline. And I think this actually lines up fairly well with the timeline that Alicia and REEF shared earlier. And this looks at how quickly we can get this equipment approved in the US context. And it focuses on the three key policy levers of standards and codes, regulatory signals, and market readiness. Today, I'm just going to focus on these standards and codes, but it's just worth mentioning that there is a lot of other important work going on in these other areas as well. On the standards and code side, the most time-sensitive priority is advancing and expediting research and testing. So that top left arrow is where we're at right now. And if we go to our next slide, we'll see a zoomed in timeline of just the standards and codes. Those transparent extensions represent a lag time, which is dependent on what capacity and type of equipment testing is currently in the works for. For example, there's no larger charge direct systems that are currently being tested, and that makes up a lot of the US market. So there's research that's still needed to address a lot of the common US market types. The next 2 years are really going to be critical to determine if we're going to stretch into 2033 to update the vast majority of US system architecture types in terms of AC heat pumps. The updates to the standards and codes need to be completed by early 2027 to meet that deadline for incorporating them into the 2030 model building codes. And then, of course, we still need EPA to snap them and for state and local building codes to adopt them as well. So there's a lot of work to do on an extended timeline. If we go to the next slide, we can see there is good news. There's ongoing research and risk assessments on residential monoblock air-to-water heat pump configurations and self-contained AC and heat pumps. Some of the diagrams here. And based on this research underway and the work that UL and ASHRAE have taken on, these are the equipment types with the greatest likelihood of being included in the 2028 UL 5th edition standard and the 2030 model codes update. This, of course, assumes that research is concluded in time, the standard committee can review it, and that it favors the development of A3 technology in certain applications. If we go to the next slide, we can see that there are a few different pathways, and right now we are in this top blue one. This covers about 20 to 25% of U.S. household AC use, and it's the most likely outcome at present because that's where the research is happening. Standards bodies, understandably, aren't going to move until they have some data they can review, and these larger charge direct systems that makes up so much of the U.S. market have not had any testing started. Now, that second green box would enable a much larger portion of the market. That would be if we harmonize with IEC fully in terms of their charge sizes. That would be almost 80 to 90% of the US market. However, larger capacity systems above 50,000 BTUs would still remain outside of R290 feasibility in a direct system. So those would need indirect or other alternatives. Now, that third box could open up a pathway that gets nearly all U.S. Equipment able to transition to R290 or other hydrocarbons. This would, of course, require a deep examination of safety and feasibility of allowing greater charge sizes for direct systems between 1.5 and 3 kilograms. So if we go to the next slide, these are the architecture types that orange box could enable, the common types in the US. And these differ substantially to what's used globally in other regions. A much higher portion of the US building stock is constructed with these ducted or direct split AC and heating. And all of the most common types of heating in the US are this direct expansion system, single loop refrigerant that physically enters the indoor space, of course, making a greater safety potential hazard if that is a flammable refrigerant and there is a potential ignition source. So the good news is, again, some of these direct systems for hydrocarbons have already been commercially introduced elsewhere, although to a lesser extent as the indirect systems. There are a number of companies that have developed R290 ductless mini split models in China and India and are in the process of introducing those in the European market. So going forward, what does the US need to do to catch up? If we go to the last slide, well, it's obviously a big opportunity to do the right thing for the climate and the environment, but it's also a big chance for OEMs to drive innovation and to lead the global market. The research has begun on that, what I'll call low-hanging fruit equipment, of that indirect equipment and some of those smaller charge systems. But if we want to reach the whole US market, we're going to need to invest in additional research for direct mini split systems, ducted residential and rooftop systems. I think that will do it for me.
Thanks so much, Chris. I really have to say I appreciate the graphics, especially. This is as you were running through, this is a very complicated, or there's a lot of moving pieces, I guess, to this picture for codes and standards. So again, I appreciate the graphics in explaining all that. And you touched on that it's not just the refrigerant gas, it's also about indoor versus outdoor, it's about charge size, it's about equipment design, which I think is all a great segue over to Cheryl to talk about what California is doing to answer some of those questions. So over to you, Cheryl.
Thanks, Alicia. All right, we can go with the next slide, please. So yeah, I want to start with sharing about California has, a strong legacy of reducing greenhouse gases and has been a national leader in reducing HFCs or hydrofluorocarbons from the early days of climate action. California is particularly committed to reducing short-lived climate pollutants like HFCs because of their disproportionate climate impact in the near term. CARB has adopted several early action measures to reduce HFC emissions under AB 32, which was passed in 2006, including our refrigerant management program established in 2009. SB 1383, passed in 2016, focused on short-lived climate pollutants and specifically mandated a 40% reduction in HFC emissions from 2013 levels by 2030. And meeting this target is one of the main drivers of our HFC policy work. Since then, CARB has adopted regulatory measures, and additionally, the California legislature has passed new bills focused on HFCs, which I'll discuss in a bit more detail in my following slides. Additionally, our F-gas reduction incentive program, or FRIP, has received a total of $66 million from the California legislature. And I'll share some more details about how we're using FRIP funding to support a market transformation for the refrigeration and air conditioning sectors. Finally, I'll highlight that this brings us to California's long-term goal of achieving carbon neutrality no later than 2045, as directed by AB 1279. All of our HFC climate work is directed at achieving a low carbon future. Next slide, please. So as I mentioned, California has been directed to reduce HFC emissions and to make progress towards our SB 1383 emission reduction target. CARB passed a first of its kind HFC regulation in 2020. This places GWP, or global warming potential limits, on the refrigerants used in stationary air conditioning and refrigeration equipment, shown here on the left. These are the largest sources of HFC emissions in California. Also in 2020, Congress passed the AIM Act, which lays out a national HFC phase down, shown here on the right. It also directs the US EPA to adopt rules to implement this phase down, and this national phase down also aligns with ongoing international phase down of HFCs per the Kigali Amendment to the Montreal Protocol, ultimately resulting in an 85% reduction in the production and consumption of HFCs in the US by 2036. CARB's regulatory work paved the way for federal adoption, and the US EPA adopted similar GWP standards in 2023 in their final technology transition rule under the AIM Act. And a national transition for all HVAC equipment was completed in 2025 to meet these new GWP requirements. I'll also note here for context that these requirements apply to space conditioning heat pumps only. So there's currently no refrigerant standards for heat pumps that are solely used for water heating, like heat pump water heaters or pool and spa heat pumps. Next slide, please. So next I want to highlight California's SB 1206, which was passed in 2022, which lays out the future of HFCs in California. There's two parts to SB 1206. The first prohibits the sale of bulk or newly produced high GWP HFCs on a phased-in timeline and requires the use of reclaimed HFCs to be used for servicing the existing equipment, as shown here on the top of the slide. The second part of SB 1206 directs CARB to write an assessment report specifying how to transition all HFC sectors in California to ultra-low GWP or no GWP alternatives no later than 2035, and then initiate rulemaking to achieve that transition. The assessment will include an analysis of the refrigerant reclamation industry from the California Energy Commission. It'll also include recommendations for workforce development and training, how to increase the adoption of new technologies, and also the role of incentive funding to support a successful transition of the market. We plan to release a draft report for public comment later this year, and then a final report would be released after that. Ultimately, SB 1206's message is that California's future is ultra-low GWP and HFC-free. Next slide. So now I want to transition into sharing a bit about our incentive program, FRIP. Financial incentives play a really important role in transitioning the market beyond regulatory measures. Right now, we are currently implementing round 2 of FRIP with a total of $65 million in funding from the legislature to promote the adoption of climate-friendly technologies and alleviate market barriers. with the North American Sustainable Refrigeration Council, or NASRC, as our third-party administrator. We chose NASRC because of their valuable knowledge about the refrigeration sector, and they've helped us develop many of our sub-programs for FRIP. FRIP is really taking an emphasis on a holistic approach to truly supporting a market transformation in California. This includes grants for the adoption of new climate-friendly technology using ultra-low GWP refrigerants. This also includes funding for workforce development programs, as well as funding for research to support the refrigerant transition. And lastly, also providing funding for a circular economy of recovery and reclamation of refrigerants from legacy equipment as they are decommissioned at their end of life. This is really important as it helps reduce emissions, and it also prevents stranding existing equipment still using these higher GWP refrigerants. Next slide, please. So with these funds, we've currently launched several sub-programs for FRIP highlighted here. An important sub-program is focused on reducing emissions from industrial and commercial refrigeration systems and alleviating cost barriers for the adoption of new ultra-low GWP refrigeration equipment. This is currently a first come, first serve program, which is still currently accepting applications through March 31st. And so far, we've awarded $19 million across 61 projects in California. Next, FRIP is also supporting a successful industry transition for the refrigeration sector by pairing the installation of these new ultra-low GWP refrigerant technologies with targeted workforce development. FRIP has also funded 2 literature review projects, so CARB can best understand the current science on the environmental and health impacts of degradation products of next generation synthetic refrigerants. The goal of this is to avoid the unforeseen circumstances of synthetic materials that have happened with previous generations of refrigerants like CFCs and HCFCs, which were ozone depleting substances. Recent research has shown that some of these next generation refrigerants like HFOs can degrade into highly mobile and persistent chemicals such as TFA or other high GWP gases such as HFC-23. Next, we're using FRIP funding to help increase the recovery and reclamation of high GWP materials from the residential HVAC sector, where refrigerant recovery rates are low, through our Refresh pilot program. The Refresh pilot is being conducted in partnership with the California Energy Commission's Equitable Building Decarbonization statewide direct install program, as well as 2 national US EPA certified refrigerant reclaimers, AGAS and Hudson Technologies. CEC's program is replacing fossil fuel burning water heaters and furnaces with heat pump technologies. And we anticipate that this program alone could remove over 10,000 furnaces and refrigerant containing air conditioner units. FRIP funding will be used to support the refrigerant reclaimers and also buyback values of the recovered refrigerant that's paid directly to the contractors and technicians participating in the program who are recovering this refrigerant from retiring air conditioners. And then our most recent sub-program, very relevant to today's topic, is for a complete risk assessment of residential monoblock air-to-water heat pumps using A3 or flammable refrigerants. This will be used to inform the codes and standards setting organizations in the North American market. I'll share a little bit more detail about this on the next slides, but also want to point you to visit our website, fripfunding.com, to keep up to date and learn about new sub-programs coming. Next slide, please. So back to the risk assessment, I'm excited to share that CARB recently awarded a research grant to the Air Conditioning, Heating and Refrigeration Technology Institute, or AHRTI, in partnership with AHRI, Oak Ridge National Lab, and also very importantly, fire service representatives. This risk assessment project was identified as a high priority research topic from a working group which CARB participated in, established by the White House and the US Department of Energy in 2024. The working group included a wide range of participants and industry experts, which worked together to identify necessary research projects and topics needed to support a successful advance of the adoption of next generation ultra-low GWP refrigerants in HVAC technologies. This risk assessment project is looking at residential A3 monoblock air-to-water heat pumps. It was actually previously funded by the US DOE. However, that funding fell through with the change of administration. And fortunately, CARB, through our FRIP program, was able to step up and fund this research quickly and released an RFP so that way we could award this grant and keep this really important research moving forward. CARB and other California state agencies like CEC, we are technology neutral in our approach in supporting research like this, and we want to make sure that there's a suite of technology options for the ultra-low GWP transition, and we see that supporting flammable refrigerant research like this helps make sure that the future of the HVAC sector has options for an ultra-low GWP future. Next slide, please. So finally, I'm just going to go over some key tasks about the research risk assessment project. These are all available in the solicitation on our FRIP website. An important part of this project is the advisory panel. And this is to be able to solicit really technical input from key organizations throughout the project timeline and ensuring that the project objectives align with our expectations and the safety standards setting organizations' expectations. The panel will include manufacturers, trade groups, environmental organizations, and safety standard setting organizations, and fire service personnel. The research is going to consider at least 2 representative products and installation configures, as well as to be used for computational fluid dynamics or CDF modeling, and there will be at least 20 different modeling scenarios to be considered. The risk assessment will also include a complete risk analysis, including the effectiveness of potential mitigation strategies for any risks identified during the project. And this technology type, as Chris mentioned in his presentation, is currently being deployed in Europe and other parts of the world right now. And so this risk assessment is really intended to inform the codes and standards setting organizations here in the US, so that the safety standards can be updated and allow similar technologies to enter the North American market. Finally, as Chris also mentioned, the timing of this research is really important, and our goal is that the study informs the current revisions of the 5th edition of the UL 2-40 standard, which is currently underway. CARB's goal is that the results of this risk assessment feed directly into the safety standard process. And next slide has contact information for my team, so feel free to reach out if you have questions. We're always happy to connect with stakeholders. Thanks.
Cheryl, thanks so much. And I just really appreciate how California is really looking at all the pieces of that market transformation and tackling it all. So it's fantastic work. I just want to remind people to put their questions into the Q&A as you think of them, and we'll pull them all up at the end. And then I want to quickly pivot over to Robert. I'm really excited to hear about Eris's work and hear how some of this technology is actually getting deployed right now, and all the information, Robert, that you're going to share with us. So thank you. Over to you.
Yeah, thank you very much. I'm happy to be here today, and yeah, this is exciting times to be able to kind of share some of the work that Eris has been doing, but also to see all the other people out there that are really working towards this goal. I think from my perspective, I'm gonna give it more from a manufacturer, also a designer and a deployer of technologies, and what this means for us and why we're really interested in it. Hopefully that'll give another perspective rather than just this tremendous amount of great information about sort of the pathway that we're on and why. So first I want to stop and talk for a moment about air to water heat pumps, so that anyone that's not clear on what that technology is and then how we're able to utilize different refrigerants in a different way, I guess. So an air to water heat pump is essentially like other heat pumps, if we're talking about air source heat pumps, in the sense that we are either extracting energy out of the air or we're taking it from inside the building envelope and putting that energy back outside. But the big difference is that we are going through, in monoblock configurations, a plate heat exchanger. And so we're using a hydronic loop that we then transfer energy inside the building envelope, which we can do a lot of amazing things with that. We can do combi systems that do heating, cooling, and hot water from the same outdoor unit. You can use all the kinds of different heat emitters that are available when you have water. So from a system point of view, there's lots of reasons to do it this way. But from a refrigerant point of view, one of the byproducts of this is that it's considered an indirect system. And so that we are the refrigerant side of things, the compressor and the refrigerant itself is wholly contained in the outdoor unit. And so that's the basis of, again, a lot of what we can do. It's also the basis of why Europe has been able to transition to A3 refrigerants at a much faster rate, because air to water is actually the dominant form of heat pumps in Europe today, as opposed to the United States and North America. Next slide. So why R290 then? Why R290 in air to water heat pumps specifically? And we'll talk about comparisons against other refrigerants, but there's a lot of reasons, as again, someone who's putting these systems into buildings, into homes, that we would like to use this refrigerant in our heat pumps. Currently we use R32, which is a very decent refrigerant, and there's a lot of reasons that, you know, I believe that it really is the right choice for some things. But when we look at R290, it has a couple attributes that go above and beyond just it being an ultra-low GWP refrigerant. It is a single component refrigerant, and I think that just looking at that and the complexities around mixed refrigerant blends, and if there are any leakage and the way that the systems react to it, having one source, one single component really does help. It also helps that it's not a proprietary blend that may be hard to get at some point. Also, because of its ability to soak up energy, as it were, we can use less of the refrigerant. And especially if we're using an air to water, we're using it in a way that's less prone to leakage. One of the ways that is exciting for this technology, though, is that we can produce higher supply temperatures than a lot of other refrigerants. And it's still reversible, so we can still do cooling with the same equipment, as opposed to, let's say, CO2, which can also produce very high supply temperatures, but has difficulty in incorporating systems where it's reversible or easily reversible. Next slide. There's a little field here that doesn't seem to be showing up on the slide, that we do compare R290 against all the different refrigerants out there. And I'll just kind of give you the long and short of it. Is it's superior in almost every way, lower GWP, higher ability to soak up energy. And then there's other things that we have to think about, and that is important to us as putting the equipment out there, and is that do they contain other chemicals that, again, can break down and pose a PFAS or PFOS risk. And so across the board, R290 really stacks up really well against a lot of other refrigerants. Next slide. Oh, looks like this is the slide. So we'll go to the next one. So what Aris has been doing, because we are a startup and because we are, I would say, a little more nimble than a lot of the other companies out there, or a lot of the other OEMs, we also have a different structure. We're vertically integrated. So we not only are working on the manufacturing side, we're working on specifying all the equipment, but we're also doing the design and engineering for systems. And we are taking that even further in certain markets. We're doing the installation. So because of that, we have a lot more inherent control of the components that go in and how we put it in. And that's allowed us to really move a lot more rapidly in basically developing a dual path. Today, we are releasing or preparing a commercial launch of our R32 heat pumps and systems. But in the same time, we're actually making them so that they are easily swappable for R290 systems. And to my knowledge, we're the first company in North America to do a full demonstration of an R290 heat pump system, HVAC system for residential in North America. And we actually did it on the National Mall first, where we sent out a kit and put it together on the National Mall for part of the Innovative Housing Showcase in DC. So that was a really amazing experience. And we had a lot of interest in both air to water, hydronic HVAC, and then R290. We also did it for an event in Verge in San Jose. And right now I have a system that's installed in my house that is actually a dual system where I can monitor the differences between R32 air to water heat pump and an R290 heat pump, and really over multiple seasons see any differences in performance and comfort and all the things that are super important in the end. We're delivering an experience to homeowners, to occupants, and that's the most important part of this, not necessarily all the little building blocks that go in. And then, of course, it matters our impact to the outside environment. Next slide, please. So another couple really exciting projects that are coming up is one of them is actually in progress right now, is that we have a few grant-funded projects with a lot of amazing partners involved, including one that's been an ongoing project through a while, but now is a air-to-water system with R290 heat pumps that is going into a demonstration site in Vermont. And this is a really interesting project because it is not taking on the full load of the system. So it's a dual fuel system. So we're all going to be able to get a lot of data out of that. But we are adding things in like cooling, which wasn't in the property before. So that project is actually in the installation phase. And so we really learned a lot with working with our researchers and partners on that one, on all the things that it takes to be able to do a demonstration project in North America right now, especially one that is multi-space, multi-family. And then we have another project coming up that is in contracting stage with NYSERDA as the funding organization and RMI as the prime, with wind companies, which is an amazing property owner that is really interested in new technologies. This will be happening in the state of New York. We have a couple sites that have been identified, but we're going through the sort of feasibility stage of identifying the right fits for this project. Next. So along the way and over the last few years, there's been a lot of learnings, and this is just a short sort of summary of the things that we that have come into view, and I think I just wanted to highlight as important, which is as we talk about refrigerants, and I know a lot of organizations are focusing on the refrigerant itself for good reason. One of the things that I like to say is that the equipment, the system, is as important, if not more important in some ways, which is to say that what air to water offers you is you get to use a lot less refrigerant, whatever that refrigerant is, and you get to ultimately maintain it in a more controlled environment with less potential for leakage. And so just identifying that if anyone's at the state level looking at implementing cleaner technologies, heat pumps are great, but air to water is really an unsung hero in the way that we can bring heat pumps into the market that has a lot more benefits. Other lessons are when we talk about risk, which, I'm super happy about what CARB is doing. It's been actually a long time in the works for I've been expressing the need that we need an independent organization while UL and HRI and ASHRAE are all working on steps forward in what this is going to mean officially into the marketplace. There's a lot of learnings and demonstrations and partners that want to work on this. In the meantime, there has to be an objective guide to do this the right way. We're doing a lot on our own, but it has to come from other sources. So that's what that's going to allow for local AHJs to be able to look at something that's really informed and backed by science. And so one of those things that are coming to view too is that, look, every site has risk. And matter of fact, what we're finding is that we're walking into most sites have a major amount of risks that were there they were just not identified. And so when we put new equipment in and new projects, we have to take into account the risk that's there, and then whatever new risk that we're introducing with our equipment, then we take very seriously. And then, a lot of this is just, again, things that are learned along the way, that you really need a lot of design intelligence. You cannot do any new technologies unless you really incorporate a lot of design intelligence into the process. So that's very important. Contractor training, of course, is very important overall. But what we're finding with air to water, which is the exciting part, is that the skill set to install the systems, they're not actually working with the refrigerants. So the risks for that side is actually a lot more minimal than split systems. And when the time comes for technicians that need to be able to handle the refrigerant side, then they will be trained to do so. And so the leap to go from where we are with split systems, where pretty much any HVAC technician is going to handle refrigerants, to where we could be with air to water, is actually a really a great opportunity. Permitting is, one of these things that people just have misunderstandings about what you can and cannot do, because there's a lot of local enforcement of certain things. But what you find is that there's not a lot of you can't do this. There's a lot of what do you need to do if you're going to do it in a certain way. Are you demonstrating? Are you doing this for a permanent? Are you doing it for a temporary installation? Things like that. And we're navigating this site by site right now. So it's been a lot of learnings there. And in the end, we're a small organization. It's just we're a startup, but we're taking a lot on in really blazing trails. So we're looking for collaborators. And ultimately, I think that in the end, that there's a lot of other manufacturers who are very interested in both air to water and with R290. And I know some that have already been looking to do demonstration projects. And so we'd be happy to share learnings with them and collaborate with them. And so that would be great. Next slide, please. So I'm just going to leave with a little, funny little anecdote story, at least from my point of view. This is from a family vacation. We go travel from the Pacific Northwest out to Montana every year usually. And, a lot of the conversations that happen at the sort of official arena and with, we talk about safety, we talk about all these things. It can get very heavy, and it's very important to look at any new product and existing products from a point of view is how do we make them safe, for sure. But it's just interesting because we also live in a world where a lot of things out there are used that, their safety factor, if you were to try to bring them into products today, they may not happen. But one of the interesting things that I think about is just utility. Like, what are the reasons that we should be adopting new things? We should get more out of them. That's one of the reasons. We should get a better experience. And yes, we should make the world a better place and not a worse place, for sure. But you think about, passing this truck, and ultimately I did crunch the numbers finally, because I knew that there were some interesting numbers here. But look, if you took the propane that is in this flatbed trailer, that again, it's a whole lot of potential energy right there, and you put it into furnaces and you used it once through combustion, I mean, you'd get a lot of BTUs. You get 410 million BTUs of energy out of it. I mean, that's one of the things that we can't deny, is that there's a lot of potential energy in some of these fuel sources. But if you look at it a different way, and you actually were filled 5,400 air to water heat pumps with each of them about 1.6 kilograms, you can actually produce 80,000 BTUs an hour by utilizing that refrigerant or that gas in the heat pump. And if you calculate that over 15 years of life, even after 15 years you could recycle that, you're ultimately able to deliver 16.2 trillion BTUs of energy. So that's 40,000, almost 40,000 times the energy delivered. So that's what I'll kind of leave you with, is that really, I know we all want to get to the same place. Even people who I think are on a different ideological viewpoint of things, is that we all want to make life better for people that we love, and a more stable place to thrive in. And in the end of the day, everybody, I think, appreciates better utility, better use of resources, because we're going to need that. And it's also going to help us with other problems like the cost of energy. So I'll leave it there and turn it over to everybody. Thank you.
Thank you so much, Robert. This is my new favorite stat. I think it's really good. And thanks for, really just grounding us in the implementation and what it looks like from your perspective. We just have a short time left. Apologies for the shorter time for Q&A, but I think what we'll do is we can take the slides down. Jamie, thank you. And then we'll just have the speakers on in. I'll just do a quick round of a question for each of you to wrap up today. And so these are coming from the audience here, and starting with Chris. I think this is best suited for you. The question is asking if you can compare a current A3 refrigerant capacity limitations in the US and Europe. So you had some of those slides talking about charge limitations. It's asking what changes in charge limits can we expect in the future in the US?
Yeah, so I think two things here. The one is there's capacity and there's charge size, which are different but related, obviously, in terms of you need a larger charge size to have a larger capacity. Equipment in Europe is typically a little bit smaller because their home size and footprint is just typically a little bit smaller. So there is some differences there between US and Europe, just in building design and equipment design. But to the charge question, the US currently has a cap at 114 grams for any system, whether direct or indirect, whereas in Europe, they can go up to 988 grams for a direct system and almost 5 kilograms for an indirect system, like the kinds that Robert was talking about. Right now, we are headed for a path which is, I would say, probably going to enable indirect systems to be around that 5 kilogram charge limit. But that's obviously dependent on some of the testing that Cheryl and other folks are kicking off as well. On the direct charge systems, the only testing which has been looked at so far is the smaller charge systems. I can't remember exactly the size off the top of my head, but it's less than a kilogram for sure. So that testing needs to get underway if we're going to get anywhere close to getting those larger direct systems in the US.
Great, thank you. Okay, over to Cheryl. Cheryl, this is a very specific question, so I'm going to give you an out just from the beginning. We can certainly get back to people after this webinar with answers. The question is about the computational fluid dynamics, the CFD modeling that you talked about, and is wondering if what's being modeled represents units that are sitting on stands of at least 12 inches in height. So it's looking for, that positioning of the unit.
Yeah, I will say I don't know off the top of my head. I can share that, we're looking at, I think maybe 6 or 7 different installation scenarios right now, but we're still working out kind of the final details of the entire project scope and what's actually going to be included in the modeling, because as you can imagine, there's so many different scenarios that we could model, but there's only so much funding we have. So we're trying to be really strategic about thinking about what installation configuration and then what potential leak scenarios we'll be considering. So yeah, that's what I can share at least.
Yeah, and that's really helpful to understand where you're at. And I think it also brings up a question that we do not have time to get into here, but it's on some kind of standardization between testing so that, there aren't any gaps left and there's some agreement on what's going to cover it all. So maybe we can
so
get
we're going to be working. Yeah, I'll say we're working, really closely with an advisory panel that we've set up with, experts in the field that have a lot of technical background on this topic, and making sure that we are considering the most relevant installation configures. So whether that's, looking at, 12 inches of height above the ground, but then also proximity of windows, doors, egresses, walls. We might be considering a rooftop installation. So we're looking at sort of all of the options right now, and then prioritizing what is most important for this project.
Great, thank you. And Robert, I'm going to give you the last word. You know, you're working, you do a lot of things as you explained, but you're also working directly with end users. And of course that's, you know, REEF is working with end users too. So I appreciate that it's really important to make sure that they're educated, they understand, you know, in your case, you know, what you're offering to them. And I wonder if you could share some insights into that piece of your business. Like, how do you feel like you have to do a lot of education for homeowners? Is it a pretty easy sell? What are the things that matter?
Yeah, I'll answer that, and I'll be able to hit two of the questions that are up there right now too, which is that we're not selling directly to homeowners to be like, oh, someone wants an R290 heat pump, come and, you know, hit us up and we'll ship you out one. We're not actually doing that in our regular system anyway. We're working through usually builders and contractors, but making sure that there's a little bit more involved because we're doing it a little bit differently. That's this stage. So I would say that the partners that we're working with to deploy our technology, yes, there's a tremendous amount of education involved about the total of what is going on there. And of course, around anything related to, well, we are using this specific piece of technology also within the system. Here's our objectives. And so, yeah, that is a big part of it. And I would say that we're more open to more of those projects. So that's how we're treating R290 is that, look, if it's a research project, and again, that could be localized, could be a smaller project. It doesn't have to be these bigger ones that are, you know, big grant funded projects, but there has to be some learnings involved and everybody has to be in it for those reasons, that they are really motivated by all the learnings that can come from it. And those are the projects that we take on. And that way that we're all in the boat to educate each other on all the things that we need to do and do it right. Yeah, so I think that someone had a question about COPs and whatnot, and I'll say, yeah, you can hit me up to get any detailed stuff. But I will tell you just offhand that under those same conditions, you know, existing refrigerants and R290, there isn't huge differences. There's just more differences in how you can push temperatures. And those will also affect the COPs. So.
Great, thank you so much. Yeah, I see some questions came in late, so apologies not to get to everything, but it's helpful to understand what your model is, Robert. So that's great to know that there's other players involved, and that is like how you do it. So that's awesome. We are going to wrap up. Like I said, we will share with everyone a recording and a link to slides and so forth, and we have some resources on our website. So we're really happy that you joined us for this conversation. If you have any feedback, feel free to share that. And I really want to especially thank the speakers. I think that this conversation just was really benefited from the breadth and depth that you all could cover. And this is really important as heat pumps just really take off and deploy all over the place. We want to get it right the first time. So thank you. And thanks everyone for joining us. Take care.